Hello everyone, this is Asha from Sri Venkateswara College of Engineering. Today I'm here to present you an video assignment on an improved transport layer protocol for wireless sensor networks. Myself Asha from 5th SEM in Abstract. So in Abstract we learn about what the research paper is on and how we are going to do the work, and this is like an overview of the paper. So in abstract, we have wireless sensor networks, WSNs. So WSNs are nothing but wireless sensor networks. These are a kind of communication networks having independent sensor nodes that form multi-hop ad hoc networks to transfer data. So these networks having independent sensor nodes, this can perform multi-hop ad hoc networks to transfer data. So in the past few years, various transport control protocols in wireless sensor networks, which is WSNs, have been developed and proposed in the literature. In this paper, we have analyzed pump slowly, fetch quickly, PSFQ. PSFQ is abbreviation of pump slowly, fetch quickly protocol, and presented an improved transport layer protocol for wireless sensor networks. So the improved protocol has been analyzed based on various factors such as average latency and average error tolerance, and it has found that the proposed protocol is better than PSFQ, which is PSFQ is can be said as pump slowly and fetch quickly network or a protocol in terms of this factor. Now we'll see through the introduction. So the wireless sensor network, which is called as WSN, is a self-organized distributed system consisting of one or more base stations, which are usually called things, and perhaps tens of or thousands of sensor nodes sprinkled in a physical area. So integration of this of the information sensed through the sensors, computations on that and wireless communications make the sensor node able to gather physical data, process that data to obtain fluid informations and reports to state sinks. So the sink can query the sensor nodes for more information. WSN, which is also called as wireless sensor network, have several characteristic features. So the major focuses in this paper is on the design of transport layer protocol for wireless sensor network (WSNs), transport layer protocol are used to mitigate congestions and reduce packet loss to provide fairness in bandwidth allocation and to guarantee end-to-end reliability. However, UDP and TCP transport protocol, which are currently used for the internet, cannot be directly implemented for WSNs, which is wireless sensor networks. For example, UDP does not provide delivery reliability that is often needed for many sensor applications, nor does it offer flow and congestion control that can lead to packet loss and unnecessary energy consumptions. Next, we have the related works. So the for WSNs, various transport layer protocols have been designed to address various issues such as congestion control, reliability, or more. A brief summary of the related protocols is provided in the sections. So the STCP, the Sensor Transmission Control Protocol, is a generic end-to-end upstream transport protocol. It provides both the congestion control and reliability by allocating the most of the responsibility of the sink. It provides controlled variable reliability, utilizing the diversity in applications. So we have Garuda, Garuda, is a reliable downstream data delivery transfer protocol for WSNs. It addresses the problem of reliable data transfer from the sink to the sensor. It's designed as a loss recovery core infrastructure and a two-stage lag-based recovery process. Then RTMC, which is Reliable Transport with Memory Consideration, is inspired from pipe flow method and provides hop by hop retransmissions to make sure all the segments can be received by the sync with 100% reliability. Next, we have analysis of PSFQ. So PSFQ is a hop-by-hop downstream transport protocol which is reliable, scalable, and robust. It uses request loss detection and notifications and local retransmissions for loss recovery and is basically designed for retasking, reprogramming applications which requires 100% packet reliability in downstream detection directions. So it consists of three operations: pump, fetch, and report operations. So the pump operations controls the rate at which the data packets are passed into the network. The fetch operations request retransmissions of the lost packet from the neighboring nodes. Lastly, the report operations provides a feedback status to the users. This way, it provides 100% packet reliability. Next, we have message transmission. So the pump operations controls the injection of packets into the network. This operation is important in controlling the timely distribution of port segments to all the sensor nodes and providing basic flow control so that the reprogramming operation does not obstruct the regular operations of the sensor network. For doing so, proper scheduling is required for data forwarding. PSFQ adapts a simple scheduling scheme which uses two timers Tmax and Tmin. So the Tmax is a timer max and T1 is the timer minimum. So it shows the minimum time and this is the maximum time. So the important task of PSFQ is to recover the last packet very quickly among immediate neighboring nodes within a controllable time frame. For that, there is a need to provide a time buffer. So Tmin gives an opportunity to a node to recover any missing segments before the next segments come from its upstream neighbor, since a node must await at least before forwarding a packet as part of the pump operation. Local loss recovery. So sensor node starts PSFQ fetch operations to do local loss recovery. It started when a sequence number gap in a flight fragments is detected. So channel impairments such as fading conditions are always correlated in time. As a result, loss of number of consecutive data packets occurs bursty loss instead of single packet loss. So therefore, PSFQ uses the concept of loss aggregation. So the loss aggregation, whenever whenever loss is detected. So this loss aggregations is detects the loss is detected. Next, we have PSFQ, combines loss such that the fetch operations deals with the window of lost packets instead of a single packet loss. Since a node usually has more than one neighbor in a dense network, PSFQ allows different segments of the loss window to be recovered from different neighbors. Shortcomings of PSFQ. So firstly, PSFQ does in a sequence forwarding of data packets. For example, if any intermediate node running PSFQ as its transport layer protocol does not have data packets 2 and has all data packets from 3 to large data packets, then this node will not forward any of the data packets to the next sensor node. In some manner, other nodes also remain ideal until they get in-sequence data packets. So this increases the time at which last data packet will reach to the target node. Secondly, there are some drawbacks into the pump and repair operations of a PSFQ. Whenever a sequence of data packets arrives, it waits for a random time between T minimum and T max for forwarding that data packet. Node does this waiting by setting a schedule. Finally, in PSFQ, same thing as above happens while repairing the data packets. Repairing of a particular data packets will be failed if radio component is busy, as PSFQ does not reschedule the data packets forward to forward it ahead. So improved transport protocol. We have out of order forwarding. As we have our in-sequence forwarding results, this is simulation scenario for PSFQ. So the packets move from 0 to 1, 1 to 2, 2 to 3, then again to the 4. The same way it goes on. Then we have comparison of average delivery ratio of PSFQ as a function of network size. So this table shows that the average delivery ratio and network size. This is the network size on ops, and this is the average delivery ratio. Next, we have to conclude, we have initially represented various protocols available for transport layer in wireless sensor networks. After that, we have presented overview of a PSFQ protocol. So we found the improved PSFQ has good error tolerance and delivery latencies. So reference, we took reference from the Chang Wang Kazim survey, and then we have referred the paper called as a generic transport layer protocol for wireless sensor networks in preceding IEEE International Conference. Then we have congestion detection and avoidance in sensor networks. So